Hey everyone. Today we're going to be talking about the equations of a quadratic function. So depending on the information provided to you, you're going to be able to write the equation of the function in either vertex form or factored form. In vertex form, the equation is y is equal to a x minus h squared plus k. You need the vertex and a point. In factored form, the equation is y is equal to a x minus p and x minus q. For this form, you need the zeros and a point. We're going to try some examples now, and in these examples, you want to be able to look at the diagram and decide which is the most appropriate form. So, for the first question here, I have two zeros. Sorry about that. I have two zeros here, and I happen to have a y-intercept. So when I have two zeros and a point, I'm going to do this question in factored form. So you start with the general form and you substitute in the zeros. Remember, when you put them into the equation, they change signs. Then we're going to substitute in the point that I have, this y-intercept, so that I can find a. When I do so, I find that a is negative 1. And some people stop there, but that's not the end of the question. You actually have to finish the question by writing out the final equation. So y is equal to negative 1, x plus 2, and x minus 3. In the next question, again, you want to look at the graph that's given to you and decide what information you have. Well, in this question here, I have a vertex right here. And again, I have a y-intercept, which is quite handy. Because I have a vertex, I'm going to use vertex form. So again, start with the general equation and substitute in the vertex. When I substitute in the vertex, I get this equation here. I'm going to use my handy y-intercept and substitute that in for x and y. And when I do so, I'll be able to find a. So I substitute everything in, I solve for a. A comes out to be 2. Again, remember the final step, which is to substitute into the final equation. So y is equal to 2, x minus 3 squared minus 4. In the first two examples, I gave you the graph, which is really helpful. Let's say instead now, I give you information that will help you to create a graph on your own. So in question number 2, I say, the parabola cuts the x-axis at negative 4 and 6, and it has a minimum value of negative 6. I'd like you to interpret that information and place that information on the graph so that you can help understand, so that it helps you understand what it actually means. So give that a try. So when I place the key information onto the graph, I have two zeros or two x-intercepts. One is at negative 4 and one is at 6. With those intercepts, I'm allowed to find, or I'm capable of finding, the axis of symmetry, which happens to be at 1. The minimum value of negative 6 happens on the axis of symmetry, otherwise known as the vertex. So the vertex is at 1, negative 6. Now that I have this information, I can figure out which form I want to use. In this question, because I have the zeros and I have the vertex, I could pick either form, vertex form or factored form. For this question, I'm going to choose to do it in factored form. So that's where I'm going to start. So I place in my factors into the brackets, and I'm going to use my vertex as my point, this random point that I need. So negative 6 is equal to a, 1 plus 4, and 1 minus 6. I'm going to solve for a now. When I do so, I get a is equal to 6 over 25. Well, looking at my graph, and if I draw in a tentative shape, it opens up. So it's a really good thing that my a is positive, because that coincides with the graph that I have here. And lastly, I want to finish the question here by writing out my final answer, which is the equation of the graph. Y is equal to 6 over 25, x plus 4, and x minus 6. Great. All right, let's try this last question here. It says the parabola has an axis of symmetry at x equals negative 3. It has a root, which I could also say a 0 or an x-intercept at 2, and it has a y-intercept at 5. See if you can figure out what to do with this information and place it on the graph below. Okay, so when I do this, I have my awesome 0 or x-intercept here at 2, 0. I have a y-intercept here at 0, 5, and I have this axis of symmetry. Well, this is enough information. You're probably like, Mishram Tula, come on. But because I give you the axis of symmetry, and you know that 1, 0 is 5 units away on the right-hand side, that means that the other is also 5 units away on the left-hand side. So that means the other 0 is here at -8, 0. That's the clincher to the question. That's the thing that makes me realize that you're actually thinking it out and you understand the idea of symmetry. So now that I'm here, I have two zeros, so the most appropriate form that I'm going to pick is, of course, factored form. So I again start in my general form here. I'm going to use my y-intercept point as the point that I want to substitute in. So I get 5 is equal to a 0 minus 2 and 0 plus 8, and I'm going to solve for a. This time my a turns out to be negative, and looking at my graph, that makes a lot of sense because though I don't know exactly where the vertex is, it definitely is above somewhere so that my graph can look something like that. And then my final step is, again, remember to write out the actual final answer. So y is equal to -5 over 16, x minus 2, and x plus 8. So to recap, given a graph or given key information about a graph that you can actually graph yourself or create a sketch of a graph, you should be able to figure out which form, vertex form or factored form, is the best choice for you to make when determining the equation of a quadratic function. Have a good day.